Welcome back to the deep dive. Today, we are tackling a problem that I think almost everyone listening will recognize. It's that feeling of persistent cognitive fatigue.
Hmm.
You know, that sense that your brain is just constantly running on fumes, completely overloaded with information. It just refuses to focus, even though you might have just downed your second, maybe third cup of coffee.
Yeah, that feeling where the engine is running, but you're not actually going anywhere.
Exactly. So today we're diving deep into what our sources suggest is a simple, almost elegant solution. Non-sleep deep rest, or NSDR.
And this is a deep dive that was specifically requested by you, the learner.
Yeah.
You're dealing with these constant high-level cognitive demands and, well, the truth is that modern life requires a kind of performance that far exceeds what an average night's sleep can restore.
So we're going to unpack NSDR.
Right. It's a term coined by neuroscientists, and we're framing it as a reliable, quick reboot protocol for your most essential piece of hardware.
Your brain. And for this mission, we've assembled a really formidable stack of sources. We're not just, looking at meditation apps. We're going beyond that and looking at the hard clinical data.
We really are. We're talking specific 11C raclopride PET scans that can actually quantify neurotransmitter release.
Right. And high-resolution EEG studies that map brainwave shifts, plus randomized controlled trials that link these practices directly to things like cortisol reduction and even accelerated learning.
Our mission today is to move NSDR from being just another, wellness buzzword to becoming an actionable strategic tool in your cognitive arsenal.
And we're structuring this entire discussion like the protocol itself.
That's the idea. So first, we'll examine why the system crashes in the first place, the neurochemical cost of just being awake.
Then second, why a full system shutdown sleep isn't always an option. The real-world sleep barriers we all face.
After that, we'll define what the NSDR reset button actually is. We'll analyze the profound neurobiological shifts that happen during that reboot. And then finally, we'll give you the complete guide on when and how to execute it safely.
Okay, let's unpack this and jump right into phase one, why the system crashes. To really understand burnout, I think we have to start with the fundamental currency of motivation and focus. We have to start with dopamine.
Dopamine it's probably the most misunderstood neurochemical out there.
It's always called the pleasure chemical.
Exactly. It gets tagged as the pleasure chemical, but in reality, it's the pursuit chemical. Dopamine neurons, they fire at what we call a tonic or baseline level, and they're constantly releasing this chemical into key brain circuits, like the striatum.
So that tonic level is like the engine idling.
It's the baseline hum of motivation. It's that readiness potential for action.
And it's crucial to remember, according to our sources, that dopamine isn't working in a vacuum. It works alongside norepinephrine and epinephrine, all of which are catecholamines.
Right. And together they govern not just physical movement, but critically for our discussion, cognitive pursuit. When you feel motivated to hunt for an answer or to focus intensely on a problem, it's those three systems generating that state.
But that baseline, that tonic level, it's constantly being influenced by spikes and drops.
All the time, peaks and troughs, all related to our expectation of a reward. And this is where we hit the first major source of daily cognitive exhaustion, something called reward prediction error, or RPE.
Tell us more about RPE. This concept feels absolutely vital for understanding how we burn out during the day, even if we feel like we're being successful.
It's key. The RPE describes how dopamine is released, not just when you get a reward, but actually much more powerfully when you are en route to the reward.
So it's the anticipation.
It's the anticipation. The pursuit is what drives the spike. Now, if the reward you finally get is exactly what you expected, your dopamine just returns to baseline, which is fine. But here's the problem that leads to the crash. If the reward is less than you anticipated, maybe you worked for an hour on an important email, and the response you get back is just one word, like noted.
Or you check your phone for a big update and there's nothing there.
Exactly. Your brain registers that as a negative RPE.
So the system is, in effect, disappointed. What's the chemical consequence of that disappointment?
Well, the consequence is that dopamine doesn't just go back to baseline. It drops. And often it drops pretty precipitously, right below that tonic level.
You're running a motivation deficit.
You are. And if you experience these repeated, minor negative RPEs all day long, which, let's face it, is the norm in our hyper-stimulated world of notifications and micro-rewards, you are continually driving your baseline motivation level lower and lower.
That explains so much. It explains why the next task, even a simple one, can feel exponentially harder than the last. You're trying to climb out of a chemical trough just to get started again.
It's like trying to restart an engine on a low battery. That's a perfect analogy.
And this connects to something else our sources mention, this idea of limbic friction.
It ties directly into it. That heavy, dragging resistance you feel right before you try to engage in focus or start a really challenging task. That's limbic friction. And our sources suggest that overcoming this resistance is purely physiological.
It's not a moral failing.
Not at all. It requires a deliberate, maybe 5 to 10 minute warm-up period.
5 to 10 minutes of discomfort just to get the relevant systems, the catecholamines firing properly. That's a powerful insight because it reframes procrastination.
It does. It's not a character flaw. It's a physiological barrier that just needs a short, concerted push to overcome.
It allows you to introduce accountability, but without all the self-judgment.
Right. Recognizing that the initial struggle is almost mandatory, that it's just the system getting online, that can be the difference between quitting and actually achieving momentum. It's analogous, perhaps, to the difficulty in initiating physical movement you see in conditions where dopamine pathways are compromised. We need that initial push to generate tonic activity.
Okay, so we're dealing with these motivation dips from dopamine RPEs. Now let's move to the second part of the crash. That physical feeling of being wired but exhausted. We can't stop, but we can't really go either. What's driving that chronic alertness?
That's the alertness cascade.
Mm-hmm.
And it's largely driven by epinephrine, or what most people call adrenaline. High sustained states of alertness, or any perceived stress, real or imagined, involve the release of epinephrine. This happens both from the adrenal glands in your body and, importantly, from a centralized area in the brainstem called the locus coeruleus.
I remember the language used in the sources to describe the locus coeruleus's action. It sounded almost violent.
It is an apt description. The locus coeruleus projects very widely. It essentially hoses the entire brain with epinephrine.
Wow.
And this flood, it isn't inherently bad. It's a necessary mechanism because this burst of epinephrine is precisely what triggers plasticity. Is what makes the brain highly receptive to change and learning. It primes you for action and for acquiring new information.
So we need that cascade for high-intensity focus and learning, but sustaining it comes at a significant cost, which leads us to the true molecule of fatigue.
That is adenosine. Adenosine is essentially the waste product of neural activity. It just accumulates the longer you're awake.
And it functions as a molecule of sleepiness.
Yes, it binds to receptors, and it tells your brain that the pressure cooker's getting too hot and it needs to cool down.
Okay, so this brings us to caffeine, the great disruptor. If adenosine is building up, how does caffeine let us keep pushing through?
Caffeine is, it's a pharmacological mask. It doesn't destroy or clear adenosine. It's an antagonist.
So it blocks the receptors?
It blocks the receptors where the adenosine molecules would normally bind, which tricks your brain into thinking it's alert. The critical concept here is that while those receptors are blocked, the adenosine is still building up in the background.
So it's like putting a piece of tape over the oil light in your car. The engine still has a problem.
Precisely. And when the caffeine metabolizes and the molecules finally detach from the receptors, which for most people can take 4 to 6 hours, all of that accumulated adenosine comes rushing back to bind.
And that's the crash.
That is the biological basis for the profound, unavoidable caffeine crash, or that severe midday dip in energy. You are suddenly hit with hours of pent-up sleep pressure all at once.
And the only truly effective built-in mechanism for clearing all that out.
That is the single most important function of deep sleep, what we call N3 sleep, and to a lesser extent, REM sleep. Sleep is the system reset for adenosine.
And if your sleep is insufficient or it's fragmented,
then your adenosine baseline starts higher the next day. You are already fatigued the moment you wake up, which predisposes you to rely on stimulants and creates this vicious cycle of sustained, high-cost alertness. We need a way to hit reset without a full multi-hour shutdown.
Okay, so we've established the crash high adenosine, fluctuating, and low dopamine. The logical cure is sleep, but as we know, modern life is notoriously bad at accommodating the 8 hours we need. We run into these immediate physiological barriers, starting with the very clock our bodies run on.
The first barrier is circadian mismatch. The widely accepted standard is a 24-hour day, but human biology doesn't always play by that rule.
Right.
Extensive research, including some really seminal work on human chronotypes, suggests that a significant portion of the population has a natural intrinsic body clock, a free-running rhythm that's set closer to 25 hours.
A 25-hour day. That is a fascinating nugget of information. What does that 25-hour tendency actually mean for our daily existence?
Well, it means we have a built-in tendency to delay our sleep time and therefore to wake up later. Every single day, your body clock naturally wants to shift forward just a little bit.
So for anyone trying to stick to a rigid 9 to 5 schedule, or even worse, a 5 a.m. wake-up call,
You are fighting a subtle form of physiological gravity every single night and every morning. You're constantly trying to rewind a clock that just prefers to move forward.
this struggle must be most pronounced in shift workers. They often suffer really severe health consequences from this kind of circadian disruption. So how should someone who has to deal with 24-hour schedules manage this natural tendency?
The key, and this is derived from analyzing sleep laboratory data, is not to fight the 25-hour tendency, but to use it. If 24-hour schedules are mandatory, the shifts should be progressive.
Progressive, what does that mean?
It means moving from day shifts to evening shifts and then finally to night shifts over a period of several weeks for each phase. This allows the body's natural rhythm, that tendency to go to bed later, to work with the required schedule change rather than being dragged backward against its will.
That's a really sophisticated solution for shift work, but let's bring it back to the average learner who just has to get up before the sun. What if someone has to regularly wake up before, say, 6 a.m. to meet their professional or academic demands?
They need an active environmental counter-protocol. Since the sun is the primary trigger for our master clock, the suprachiasmatic nucleus, or SCN, you have to mimic or enhance sunrise artificially.
Okay, so how do you do that?
In the evening, you must ensure total darkness and quiet. This prompts an earlier release of melatonin and helps establish an early-to-bed schedule. Then, immediately upon waking, you have to expose your eyes and not through a window to bright light. Ideally, 10,000 lux for about 30 minutes.
It's a deliberate, powerful reset signal to overcome that 25-hour forward drift.
It is. It's an active intervention.
Now, beyond the circadian mismatch, chronic sleep deprivation imposes a severe physiological cost that goes way beyond just feeling tired. It impacts our metabolism dramatically.
Absolutely. The endocrine system just goes haywire when you're sleep deprived. Specifically, we see a significant increase in ghrelin levels. And ghrelin is the crucial hunger hormone, the one that tells your body, I need fuel and I need it now.
So sleep deprivation doesn't just make you tired, it literally makes you hungrier.
And not just hungrier for any food. You typically crave energy-dense, high-carbohydrate or high-sugar foods to rapidly address what the body perceives as an energy crisis.
And this chronic elevation in ghrelin.
It can lead directly to weight gain and a whole host of subsequent metabolic dysfunctions. We are talking about a systemic health breakdown, all originating from poor sleep management.
That just underscores the monumental barrier to performance and health that poor sleep presents. And we need to emphasize that this barrier doesn't have to be severe insomnia. Even small, consistent lifestyle choices can compromise the restorative architecture of our sleep.
Our sources were very clear on this. Even moderate alcohol consumption, we're talking doses as low as just 1 drink per week, can disrupt sleep patterns.
1 drink a week.
Yes. It interferes specifically with the amount of REM sleep and N3, or deep sleep. You might pass out faster, but the quality of that sleep, the actual system reset, is fundamentally compromised.
And if you compromise REM and N3, you compromise both your emotional regulation and your physical recovery, which just leaves that adenosine backlog we discussed earlier.
Precisely. And this creates what we can call the solution gap. The brain is fatigued, adenosine is high, dopamine is likely low or fluctuating wildly. But a multi-hour sleep period is impractical, or maybe your underlying stress, rumination, depression, is preventing quality sleep anyway.
And this is where NSDR comes in.
NSDR fills this void. It offers a standardized physiological mechanism to reduce stress and anxiety and clear some of that cognitive congestion when a full shutdown is just impossible.
So the brain needs a quick, deep rest, but a full sleep cycle is often unavailable. Enter non-sleep deep rest. Let's formally define this tool.
Okay, NSDR is a modern term, largely popularized by the neuroscientist Andrew Huberman, that functions as a kind of clinical umbrella. It covers centuries-old, standardized rest practices, primarily Yoga Nidra and other structured techniques like self-guided hypnosis that induce a very specific brain state.
And we need to stress, this is not just passive relaxation or, dozing off on the couch. NSDR is about accessing a highly intentional and specific conscious state of mind.
It is the state between being fully awake and falling asleep. You are inducing a profound state of deep relaxation. But the core requirement is that awareness must be maintained.
You have to actively prevent yourself from fully drifting off.
You do. And this focused, conscious relaxation is the key to unlocking the neurochemical shifts we're about to discuss.
Historically, where does this practice come from? It feels very modern, but it's clearly rooted in ancient tradition.
The lineage is deep. The Nidra tradition stems primarily from Hindu spirituality, and it's been incorporated into various practices within Mahayana and Vajrayana Buddhism. NSDR simply provides a neutral, clinical framework and terminology for these protocols that have been studied and refined for thousands of years to optimize the human rest state.
And structurally, what does the execution look like? If someone wants to try this, what are the components of a typical Yoga Nidra or NSDR session?
The practice is mostly performed lying down in the supine position, what's known as Shavasana, or the corpse pose. It has two essential phases. First, the induction of deep physical rest. Second, maintaining that deep rest while engaging in directed, intense mental focus.
And how is that focus achieved?
It's usually through specific sequential practices. A body scan, where you systematically relax and notice tension in different parts of your body. Breath awareness, often just counting the breath, or following detailed guided instructions provided by an audio track. The objective is total muscular stillness paired with heightened mental attention.
Before we move on to the massive internal changes NSDR causes, let's just zoom in on two quick covert behavioral practices that the sources mentioned. Things you can do to instantly leverage the nervous system to promote this calm state, even if you only have a minute.
The first one is incredibly simple: visual defocusing. Think about what happens when you're intensely focused or stressed. Your vision narrows. This is called foveation, the soda straw view. Your brain is in a hunting or threat detection mode, which is sympathetic alertness dominant.
So if I consciously counteract that narrow focus, I can signal to my brain that the threat is over.
Exactly. The simple, covert practice is to intentionally relax your eyes and dilate your gaze to engage panoramic vision, seeing the entire environment at once, including the peripheral edges. This action instantly reduces the intensity of the visual processing, signaling safety to the brainstem and initiating a shift toward a calmer state.
That is an immediate, actionable tool. What about the fastest physiological hack to engage the parasympathetic system?
That is the physiological sigh. And this isn't just taking a deep breath. It is a very specific breathing pattern that has been shown to be the fastest way to shift the autonomic nervous system toward the parasympathetic, or rest and digest mode.
Give us the mechanics. Why is this specific sigh so effective?
It involves 2 inhales followed by 1 long, slow exhale.
2 inhales?
Yes, the first, shorter inhale, and the second, deeper inhale works specifically to reinflate the small air sacs in your lungs, the alveoli, that tend to collapse or underinflate during periods of stress or shallow breathing. By fully reinflating them and then taking that long extended exhale, you maximize the expulsion of carbon dioxide. And since the level of CO2 in your blood is the primary chemical trigger for the vagus nerve, the nerve of calm dramatically reducing it instantly dampens sympathetic output. It's like an immediate self-administered tranquilizer.
Okay, now we get to the core of this deep dive. We're moving from the ancient practice to the hard, quantifiable science. The neurobiological shifts recorded during NSDR are, well, they're nothing short of shocking, particularly when you look at the brain's fuel for motivation.
What's truly revolutionary here is the evidence regarding dopamine dynamics. Researchers used those 11C raclopride PET scans, which are the gold standard for measuring endogenous neurotransmitter release in living subjects, to see what happens during Yoga Nidra. They focused on the striatum, which is central to movement, motivation, and reward.
And the data revealed a massive surge, right? What exactly were they measuring?
They were measuring competition. See, raclopride is a tracer that binds to D2 dopamine receptors. When the brain releases its own endogenous dopamine, that dopamine literally pushes the raclopride off the receptors.
So a decrease in raclopride binding means an increase in the brain's own natural dopamine release.
Exactly.
And what was the quantification of this process?
The quantification was phenomenal, and this is the key insight for every listener. During the practice, 11C raclopride binding in the ventral striatum decreased by 7.9%. When you translate that figure to actual neurotransmitter release, it corresponds to a remarkable 65% increase in endogenous dopamine release.
65%. That is a massive, stable flood of the motivation chemical generated simply by lying still and focusing. This completely reframes NSDR. It's not just relaxation, it's active chemical engineering.
And here is the core paradox that separates NSDR from stimulants like caffeine or amphetamines. This massive dopamine surge was associated with the self-reported reduced readiness for action.
Wait, that seems completely counterintuitive. If dopamine is the pursuit chemical, why would a 65% increase reduce the urge to move or act?
This is where we need to dive into the synaptic mechanism. The hypothesis is that this immense targeted dopamine increase causes a suppression of what's called corticostriatal glutamatergic transmission.
Okay, break that down for us.
Think of the corticostriatal circuit as the brain's primary pathway for initiating and executing goal-directed action. Dopamine, in this context, might be acting as the brake on the urgency to translate thought into movement.
So the dopamine surge isn't fueling frantic action, but rather it's stabilizing the internal system, maybe by satisfying the pursuit circuits so effectively that the immediate restless need for reward prediction feedback is just quieted.
That's a great way to think about it. It's a kind of executive loss of control that is profoundly restorative. The brain is getting a massive injection of motivational fuel, but the system that translates that fuel into external demanding action is temporarily suppressed.
It's the first in vivo demonstration that we can use conscious, focused rest to actively regulate the brain's chemistry at the synaptic level.
It is. It's groundbreaking.
Moving beyond the chemistry, let's look at the electrical activity. What state is the brain actually in during this reboot? The EEG studies provide the brainwave correlates.
The EEG studies confirmed a highly distinct state. It wasn't just a slowing down. They demonstrated a significant concomitant increase in theta activity. Theta waves, which are about 4-8 Hz, are typically associated with a deep relaxation, that hypnagogic state just before sleep, and also with access to memory formation.
That makes perfect sense for a state that's literally between waking and sleeping. Did they see other rhythms shift as well?
Yes, another study showed an increase in what's called parietic capital gamma power, alongside a decrease in alpha power. And gamma waves, which are much faster, typically 3100 Hz, are often associated with high-level cognitive function, integrated processing, and concentrated focus.
So the brain is simultaneously deeply relaxed, which is the theta, and highly focused or integrated, which is the gamma. It's a really unusual combination.
It is. This dual signature deep relaxation and integrated focus is the electrical signature of the NSDR state. It confirms that it's qualitatively different from just closing your eyes and zoning out.
And most importantly, the neurophysiological correlates were definitive on one point. This is not sleep.
Absolutely. They actively monitored for signs of non-REM N2 sleep, specifically for things called sleep spindles and K-complexes, and none were detected in any participants. This confirms a conscious state is truly maintained between waking and sleeping, which protects the learner from entering actual sleep and then waking up with that groggy sleep inertia.
The physiological benefits seem to match the neurological ones. Let's talk about the autonomic nervous system, the ANS, which is the body's master regulator of stress. How does NSDR shift that balance?
The practice produces a favorable and quantifiable shift toward the parasympathetic branch of the ANS, the rest and digest system. It actively reduces the sympathetic or fight or flight output, which leads to enhanced physical and mental relaxation.
And we can actually measure this shift using heart rate variability, or HRV.
That's right. HRV is the fluctuation in the time interval between consecutive heartbeats, and it is the best gauge we have of cardiac vagal tone. Our sources demonstrated that Yoga Nidra increases the normalized high frequency, or HF, component of HRV.
And why is increasing that HF component so important for the stress learner?
Because a low HF component is strongly and inversely related to perceived emotional stress and burnout. By increasing HF power, NSDR confirms that the vagal modulation of the heart period becomes more robust. You're objectively enhancing your body's ability to downregulate stress and recover, independent of external factors or your baseline fitness levels.
You're building resilience into your physiological operating system.
That's a perfect way to describe it.
Beyond heart rate variability, the practice has broader, immediate cardiovascular effects that indicate a kind of systemic relaxation.
We see widespread vasodilation, the widening of blood vessels. This, combined with that parasympathetic activation, results in a significant drop in both systolic and diastolic blood pressure, coupled with a reduced, stable heart rate. The physical body is just unwinding on a systemic level.
And finally, the ultimate proof of stress reduction, the stress hormone, cortisol. What did the clinical trials involving the 30-minute-long form of Yoga Nidra reveal about its impact on cortisol?
The results are striking. They found that regular NSDR led to a flatter rise in the cortisol awakening response.
Explain what that is.
It's a key measure of your HPA axis, your stress axis's reactivity. A typically sharp, high cortisol spike right when you wake up indicates chronic stress. By flattening this response, NSDR helps the body manage the transition from rest to alertness more smoothly.
Did they also look at immediate cortisol levels?
They did. Salivary cortisol was shown to reduce statistically significantly immediately after the Yoga Nidra intervention. This biochemical evidence really solidifies NSDR's role not just as a subjective mood booster, but as a potent, measurable intervention for mitigating chronic physiological stress, depression, and rumination.
Okay, so we know what NSDR does. It floods the system with motivation fuel, dopamine, it activates deep relaxation, theta, and gamma waves, and it calms the stress axis, which we can see in HRV and cortisol. Now, the strategic question, when do we press this reboot button for optimized usage?
The timing is crucial, and this takes us beyond simple stress management and into maximizing performance.
Yeah.
The most exciting finding, I think, for high cognitive load individuals is NSDR's ability to accelerate neuroplasticity and learning.
We're talking about using NSDR not just for recovery, but as a learning accelerator.
Precisely. The studies show that when NSDR is performed immediately after an intense period of focus or learning, whether you're mastering a physical skill or acquiring new cognitive information, it acts as a powerful catalyst for consolidation.
And the data on the acceleration rate is astounding. Our sources indicated that this strategic post-focus NSDR accelerates neuroplasticity by approximately 50%.
50% faster learning. But just think about the implications for someone dedicating 4 hours a day to mastering a new language or a complex technical skill. That focused rest period is essentially maximizing the efficiency of the previous period of effort. It ensures the brain successfully cements those new neural pathways.
And this happens because, as we understand it, neuroplasticity doesn't primarily occur during the high-intensity effort itself.
No, it happens during the subsequent rest and recovery period. NSDR seems to tap into this recovery mechanism during a conscious state, achieving effects that are normally reserved for deep and REM sleep.
It's the ultimate learning hack, then. The focused effort is the necessary trigger for change. It tells the brain what to rewire. And NSDR is the accelerator that makes the actual rewiring happen faster and more efficiently.
That's the model.
Beyond accelerating learning, NSDR has direct and proven benefits for mental health and resilience, as we touched on with the cortisol data.
Absolutely. By reducing stress, depression, and rumination, it offers therapeutic benefits that can help manage underlying psychological pathologies. Rumination, in particular, that cycle of negative, repetitive thought, is often linked to sympathetic dominance and high cortisol. NSDR helps break that cycle by forcing the parasympathetic shift.
And while NSDR is non-sleep rest, consistent practice can actually improve the quality of your actual sleep, making it a powerful tool for those struggling with chronic insomnia.
Yes, when used regularly, Yoga Nidra has been successfully leveraged in clinical settings for insomnia treatment. It objectively improved the duration of N3, or deep sleep, the most physically restorative phase, and it reduced the total wake duration during the night. So it helps you fall asleep better, stay asleep better, and makes the sleep you do get higher quality.
So let's talk practical application regarding timing and duration. If someone has a busy schedule, can they achieve this deep chemical reset with short bursts, or does it require a lengthy commitment?
The research is really encouraging for busy people because both short and long forms demonstrate significant benefits. Studies looking at an 11-minute short form found a robust reduction in depression when compared to a control group, so that suggests acute benefits are accessible very quickly.
But the longer duration seems to provide more lasting stability?
Correct. The 30-minute long form demonstrated superior results. Specifically, it showed significant retention of effects for stress, depression, and rumination at follow-up assessments several weeks later. So the longer form provides deeper, more sustained structural and emotional benefits.
Finally, let's consider using NSDR as a strategic targeted nap, perhaps during that natural afternoon lull.
This is the optimal time for the brain reboot. That natural drop in alertness, often occurring between 2.0 and 4:00 p.m. That's your system begging for a break. If you use NSDR, then the duration needs to be calibrated based on your preceding sleep debt.
How does the listener determine that calibration?
Okay, so if you've had moderate previous sleep, say around 6 hours, or 4 full sleep cycles, a short NSDR duration of 15 to 30 minutes is recommended.
And why that specific window?
It prevents you from entering deep sleep and ensures you wake up alert and refreshed, utilizing that dopamine surge for the rest of the day.
And if you're running on serious debt, a very short night, maybe only 3 to 4.5 hours.
Then the system needs a more substantial period of restoration. In that case, you should target a much longer NSDR period of about 1.5 hours.
90 minutes.
Right. This duration mirrors a full human sleep cycle, N1, N2, N3, and REM. By using a guided NSDR protocol for 90 minutes, you essentially maximize the system reset and minimize the likelihood of waking up mid-cycle with that massive inertia.
That nuanced timing calibrating the duration based on debt is crucial. It turns an SDR into a targeted intervention rather than just a random rest period.
That's the entire utility of it. It's allowing acute, focused neurological recovery tied to the conscious control of the autonomic nervous system and, of course, that massive beneficial endogenous dopamine release we discussed.
Right, now we deliver the operational guide. We've established the why and the when. Let's focus on the how to ensure the listener can execute this reboot safely and maximize all those neurochemical benefits, starting with the environment.
The environment is everything because you're actively trying to shut off all external sensory stimulation to facilitate the internal shift. The practice is universally performed lying supine shavasana. You need a comfortable yet firm surface, a yoga mat, a thick rug, or a bed, just ensuring your limbs are supported.
And sensory input needs to be limited. This means maximizing darkness and eliminating sound pollution.
We're aiming for total sensory limitation. Prepare the room for complete darkness. If you can't achieve that with standard shades, you might need to use an eye mask, or even makeshift solutions like black fabric.
And for sound,
To mask disruptive sounds, utilize earplugs or a white noise machine set at a consistent, non-distracting frequency. And crucially, disable all potential noise disturbances, phones, doorbells, alarms, anything that could yank you out of that deep state.
and let's just reiterate the importance of temperature control, as this directly facilitates the rest state.
The ambient temperature of the room should be kept cool. The ideal range cited for deep rest and optimal sleep architecture is between 65–68 degrees Celsius or about 18–20 degrees Celsius. A cooler environment helps the body enter and maintain the restful, low metabolic state required for NSDR.
Moving into the practice itself, the guidance component is vital, isn't it? This is different from silent forms of meditation where you are intentionally cultivating awareness without direction.
That's right. NSDR and Yoga Nidra protocols are generally followed using guided instruction, usually an audio track developed by a certified instructor. This ensures the pacing and the verbal cues, like the body scans and breath focusing, are structured to progressively enhance the depth of relaxation without allowing you to just drift into full sleep.
The core mechanism of the practice is maintaining awareness while preventing physical movement.
Yes. The mental practice focuses on cultivating awareness of your body and your breath while consciously, even intensely, preventing any physical movement. Any urge to scratch an itch or adjust your position must be mentally overridden.
And that stillness signals safety to the brain.
It does. It tells the brain that the environment is completely safe, allowing the parasympathetic system to fully take over, and the duration is key. Practice daily for consistency. The 30-minute session is the standard, though, as we said, the 11-minute short form is effective for acute stress reduction.
And circling back to the strategic afternoon usage between 2.0 and 4.00 p.m., let's reinforce that duration calibration based on sleep debt. This is where NSDR becomes a clinical tool.
Remember the calibration logic. If you had moderate sleep, 6 hours, then 15 to 30 minutes prevents deep sleep entry and maximizes that dopamine reboot. If you're severely sleep deprived under 4.5 hours, the system needs a full restorative cycle. Opt for the 1.5-hour duration to achieve a systemic reset. This structured approach moves the practice from an arbitrary nap to a finely tuned neurochemical intervention.
The specificity of this protocol is what defines it as a brain reboot, leveraging internal chemistry rather than external stimulants.
Exactly. The goal isn't just to feel less stressed, but to actively change your internal physiological state, to engineer a 65% dopamine surge and a measurable increase in cardiac resilience, all through the conscious regulation of your inner environment.
We have completed the full NSDR system reboot protocol. We've charted the brain's crash cycle, the relentless demand on the dopamine pursuit system leading to motivation debt via negative RPE, and the accumulation of that sleep molecule, adenosine.
We recognize the significant barriers to a full system shutdown, that 25-hour circadian pull, the metabolic chaos caused by ghrelin, and the corrosive effect of alcohol on sleep architecture.
We defined the NSDR reboot button as a clinical conscious rest state verified by EEG to increase powerful theta and gamma activity without any signs of actual sleep.
And we mapped the massive neurobiological reset, that dramatic 65% surge in endogenous dopamine in the ventral striatum, the favorable measurable shift to the parasympathetic nervous system confirmed by increased HRV, and the flattening of that stress hallmark, the cortisol awakening response.
And finally, we gave you the operational guide, demonstrating that NSDR is not merely a stress reliever, but a mechanism to accelerate neuroplasticity and learning by a staggering 50% when you use it strategically, immediately following intense cognitive effort.
The final insight we want you to carry forward is the counterintuitive power of quietude. That massive restorative dopamine surge recorded during NSDR was linked to a reduced readiness for action, the conscious choice to be still. This suggests that control over our inner state isn't just about reducing subjective stress. It's about actively generating the optimal neurochemical environment required for motivation and high function. You refill the tank, not by chasing the reward, but by intentionally suspending the pursuit.
So what does this all mean for your productivity and your learning schedule? If NSDR protocols show that we can accelerate learning simply by following focused mental rest after intense effort, and if focused effort is the trigger for change while NSDR is the accelerator, consider this provocative thought.
If half of your learning happens during rest, how much time should you truly dedicate to restorative states like NSDR each day to maximize both your learning rates and overall mental function? Is your current allocation of effort versus rest holding back your true potential?
Food for thought until our next deep dive.